Hi all, a very good day to all. Myself Karthika, Assistant Professor, Computer Science and Engineering in Banariaman Institute of Technology. Hope all are doing well. In our last lecture, we have discussed about intermediate codes in compiler design. Intermediate codes lies between front end and back end phases of the compiler. If you consider the postal addresses, we have from address part and to address part. Apart from these from address and to address, pin code plays a very important role in postal addresses. Our from address can be imagined similar to our high level language and to address can be imagined similar to our target machine code. In our to address, we have pin code. Pin code is a number not more than 6 digits as far as our Indian pin codes are concerned. Pin codes follow a standard format. The first digit in a pin code represents the region code, the second digit represents the sub-region code and the third digit in the pin code represents the district code, whereas the last 3 digits in a pin code represents the respective post office code. Using this pin codes, the corresponding postal addresses is recognized quickly by the post offices. Similar to the pin code, one of the most important representation of postal address, here in compilers we have 3 address code, a most important representation of our intermediate code generation, which is generated during the process of converting a high level language program to a machine language program. 3 address code is an intermediate code and it is mostly used by the optimizing compilers. In these 3 address code, the given instructions is separated into simple instructions. These instructions can then be easily translated to the machine language. Each 3 address code has at most 3 operands. The operands are a combination of assignment operator and a binary operator. 3 address code representations. 3 address codes are represented as one of the 3 forms: quadruples, triples and indirect triples. Quadruples. The quadruples have 4 fields to implement the 3 address code. The field of the quadruples contain the name of the operator, the first source operand, the second source operand and the destination, that is the result, respectively. Now let us see an example of how to form a quadruple representation. First, let us write a 3 address code for this expression. So the 3 address code can be written by using temporary variables. We have already discussed of how to write a 3 address code in detail in our previous video itself. So first, let us write 3 address code for this expression. So while writing a 3 address code, you have to consider the precedence of the operator. So while scanning from left to right, this exponential operator holds the highest priority. So first that will be evaluated. T1 is equal to E exponential f. The result will be stored in the temporary variable T1. After that, while scanning from left to right, this holds the second priority. Okay, this is the first priority and this is the second priority. So T2 is equal to B star C. So the result of B star C will be stored under the temporary variable T2. Now we have evaluated this phase. So after that, this division operator can be evaluated. So what we have to do? We have to divide T2 with T1. Okay. So B star C, the result of B star C is under T2. The result of E exponential f is under T1. So we have to divide both. So T2 has to be divided with T1 and the result can be stored under T3. Now we have completed this phase. When we check the precedence, this multiplication operator holds the next precedence. So let us evaluate this. So B star A, the result will be stored in the temporary register T4. After evaluating this, while scanning from left to right, first this addition operator has to be evaluated. So A has to be added with the complete thing. So the result of this complete thing is stored where? Is stored under the temporary variable T3. So now what I am going to do means I am going to add A with the value that is present in T3. The result will be stored in T5. Okay. So the result of this complete thing is stored where? Is stored in the register T5. The result of this B star A is stored where? Is stored under T4. Finally, you have to add T5 and T4 and the result can be stored under the temporary variable T6. So this is how a 3 address code can be generated for this expression. After generating the 3 address code, we have to represent it by means of a quadruple manner. So as told before, in a quadruple representation we have 3 fields. That is, we have an operator field, then source 1 field, source 2 field and the destination field. So you have to form a quadruple representation for this 3 address code. First column represents the operator field, second column argument 1, that is the first source field, then second argument field, that is source number 2, then finally destination. Result is nothing but the destination. And this location denotes the statements, that is where the particular expression is stored. In order to represent each and every 3 address code, you need to mention it by means of a location factor. So first, if I take this statement, T1 equal to E exponential F. So this is the first statement, that is, it is stored in the location 0. What is the operator here? Operator is exponential operator. What is the first argument? E is the first argument. What is the second argument? F is the second argument. Where the result will be stored? The result will be stored in T1. Okay. Now the next statement. The next statement will be present in the location 1. Consider that all these 3 address code is pointed by means of an array format. So it starts with the index number 0. So the first statement is present in the 0th index and the second statement in the first index likewise. That's why I am mentioning the location value as index number values. What in the second statement, what is the operator? Multiplication is the operator. So mention star in OP. Then what is the first argument? B is the first argument. What is the second argument? C is the second argument. Where the result is stored? The result is stored in the temporary register T2. Next, T3. So T3 will be stored in the location 2. So here what is the operator? Division is the operator. What is the first argument? T2 is the first argument. What is the second argument? T1 is the second argument. Where the result is stored? The result is stored in T3. Next statement is stored in the location 3. So if for this statement, what is the operator? Star is the operator. What is the first argument? B is the first argument. What is the second argument? A is the second argument. And where the result is stored? It is stored in T4. Next, this statement is stored in the location 4. So for this statement, what is the operator? Plus is the operator. What is the first operand? T3 is the first operand. And what is the second operand? A is the second operand. Where the result will be stored? It is stored in T5. Then the last statement is stored in the location 5. For the last statement, what is the operator? Plus is the operator. What is the first operand? T5 is the first operand. What is the second operand? T4 is the second operand. Where the result will be stored? It is stored in T6. So this is how a quadruple representation of a 3 address code will be. You have to split the 3 address code by means of some operator, argument 1, argument 2 and result field. For example, if we have a statement like x is equal to operator y. So here this is what? This is a unary operator. So this unary operator is represented by placing OP in operator field and y in argument 1 field. See, in quadruple representation we have argument 1 and argument 2. 2 fields are there. You have to place y in argument 1 field and the argument 2 field is left blank and X is placed in the result field. Okay. If a statement like this is given, param1, so this is what? This is like a function. So here we have to place param in operator field, and T1 is what? T1 is the argument, and this has to be placed in argument 1 field. Neither argument 2 nor result field are used here. Next, if we have conditional and unconditional jump statements, so these statements are represented by placing the target labels. In conditional jump and unconditional jump, we will have some target labels, no? Some go to a target label will be there. So that target label has to be placed in the result field. So these are the 3 important things you have to be remember it while forming the 3 address code in the way of quadruple representation. So next type of representation is triples representation. In triples, use of temporary variables is avoided and instead references to instructions are made. The advantage of triple over quadruple is time and space is reduced because here temporary variables are avoided. And the disadvantage of triple representation is not suitable for optimization compilers where quadruples are best suited. Let us see an example of our triple representation. The same 3 address code I have taken. So in triple representation, the usage of temporary variables is avoided. So the table will be reduced like this. We will have only location field, operator field, argument 1 and argument 2 field. The result field is avoided. So for the first statement, the location is 0. What is the operator? Exponential is the operator. Argument 1 is E, argument 2 is F. Then for the second statement, it is stored in the location 1. What is the operator? Star is the operator. Argument 1 is B, argument 2 is C. For the third statement, it is stored in the location 2. So what is the operator? Division is the operator and T2. Since we are not using temporary variables, you have to use the location field instead. So where the result of T2 is stored, the result of this T2 is stored in the location 1. So you have to represent 1 here. And where the result of T1 is stored, the result of T1 is stored in this location, that is in 0th location. So you have to use 0 as the second argument, right? Next, the next statement T4. So this is stored in the location 3. What is the operator? Star is the operator. What is the argument 1? B is argument 1. What is argument 2? A is argument 2. Then for the fifth statement, it is stored in the location 4. What is the operator? Plus is the operator. And what is the first argument? T3 is the first argument. So where the result of T3 is present. So the result of T3 is present here. That is, it is present in the location 2. So you have to use 2 as the first argument and the second argument is A, right? Next, for the next statement T6, where it is stored in the location 5. Operator is addition operator. Argument 1. Argument 1 is T5. So where the result of T5 is stored? T5 is stored in the location 4. So 4 becomes the location 4 becomes the first argument, and T4, second argument is T4, where the value of T4 is stored, that is B star A is stored. It is stored in the location 3. So the second argument is 3. So thus our triple representation will avoid the usage of temporary variables. This is the difference between quadruples and triples. In quadruples we will use temporary variables, whereas in triples we will use the location pointer values itself instead of temporary variables. Next representation is indirect triples. Indirect triples, it uses an additional instruction array to list the pointer to the triples in the desired order. It uses what? It uses an additional array. Thus, our indirect triple uses pointers instead of positions to store the results, which enables the optimizers to freely reposition the sub-expressions to produce an optimized code. Okay. So, in triples we have seen a drawback that it is not suited for optimizing compilers since it uses the location value itself. So, that drawback is avoided in indirect triples. Instead of using the location itself, it will uses the pointer of that location instead. Okay. Let us see an example, then you can understand it better. Indirect triples. So, first let us fill the table. So, this table is similar to our triple table only. So, I am writing as it is, as we have filled in our triple table. For the first statement and for the second statement, operator is star, first argument is B and second argument is C, and for the third statement it is stored in location 2. The first argument is the operator is division operator, first argument is 1 and the second argument is 0. For third statement it is in the location 3, the operator is star, first argument is B, second argument is A, and the next statement is stored in the location 4. The operator is plus, the first operand is 2 and the second operand is A. Then the next statement is stored in the location 5. The operator is plus, the first argument is 4 and the second argument is 3. So, this table is same as like our triple table. Added to it, we have another table which indicates the order of execution. So, this is an array for maintaining the order of execution. For indirect triples, we have to just write down the extra array for noting down the pointer values of the location. So, in the 35th index, the location value of 0 will be stored, in 36 the location value of 1 will be stored, in 37 the location value of 2 will be stored, and in 38 the location value of 3 will be stored, and in 39 the location value of 4 will be stored, and in 40 the location value of 5 will be stored. Okay. Thus, this array representation helps to quickly determine the position of the location where the value is stored. Now, let us check with another example. So, this is the example. First, let us write the 3 address code for this expression. First, let us evaluate this unary operator. So, T1 equal to U minus C. Then this unary operator is multiplied with B, that is T1 is multiplied with B and the result is stored in T2. B is multiplied with T1. Now, we have evaluated this expression. Now, coming to the next expression, here also unary operator is there. First, let us evaluate it, U minus C. So, the result of the unary operation is stored in T3. Next, B is multiplied with this unary operator, that is T3. B is multiplied with T3 and the result is stored under T4. Finally, the result of this complete expression is under T2, the result of this complete expression is under T4. We have to add both. So, T2 and T4 is added and the result is stored in T5. So, complete value of this expression is stored under T5. Now, this T5 value is assigned to A. So, A equal to T5. So, this is the corresponding 3 address code for our expression. Let us represent this 3 address code in 3 types of representation: quadruple, triple and indirect triple. Quadruple for this unary operation, location is 0, operator is what? Operator is U minus, argument 1 is C, result is T1. For the next statement, location is 1. What is the operator? Star is the operator. What is the first argument? B is the first argument. Second argument, T1. Then the result is stored in T2. Next, for this expression, it is stored in the location 2. Operator is U minus. The first operand is C. The result is stored in T3. And for the next expression, it is stored in the location 3. What is the operator? Star is the operator. First operand is B. Second operand is T3. And the result is stored in T4. And for this expression, it is stored in the location 4. The first operator is plus, the first operand is T2, the second operand is T4, and the result is stored in T5. And for this expression is stored in the location 5. Operator is assignment operator, first operand is T5, and the result is stored where? It is stored in A. So this is quadruple representation. Next, triple representation. In triple representation, we will avoid the usage of temporary variable. So for the first statement, stored in the location 0, the operator is U minus and the first argument is C. And for the next statement, it is stored in the location 1, operator is multiplication operator, first argument is B and the second argument is T1. Where T1 result is stored? It is stored in the location 0, so you can mention 0 in argument 2. The next statement is stored in the location 2, the operator is U minus and the first argument is C. For the next statement, it is stored in the location 3, first operator is multiplication operator, first argument is B, second argument is T3. So where the result of T3 is stored? T3 is stored in the second location, so you can use second location as the argument 2. And the next statement is stored in the location 4. What is the operator? Plus is the operator. Where T2 is stored? T2 is stored in first location, and where the result of T4 is stored? It is stored in third location. So you can mention 1 and 3 in the argument field. Next, last statement is stored in the location 5. So what is the operator? Assignment operator. And where the result of the T5 is stored? It is stored in the location 4. You just mention 4 alone. So where the value of the T5 is stored? It is stored in the location 4. And where it has to be assigned? It has to be assigned to our operand A. Okay. Since it is an operand, you have to mention. If it is a temporary variable, it is no need to mention it. Whereas if an operand is used, you have to mention that operand. So A is used in the argument 2. Okay. The result of that is the value stored in the location 4 is assigned to the argument A. So this is the meaning of this statement. Next, indirect triples. So this box is similar to our triples, triple representation. So let me write it as it is. Next, we have to mention an additional array for storing the address values. 36, 37, 38 will contain the location value of 2 and 39 will contain the location value of 3 and 40 will contain the location value of 4 and 41 will contain the location value of 5. So this number is just our index number. You can use any numbers. So this is how an indirect triple representation will be. Next, we are going to see about translation of assignment statements. So in the syntax directed translation, assignment statement mainly deals with expressions. The expression can be of type real, integer, array and records. Consider the grammar. S gives id equal to e equal to e1 plus e2, e equal to e1 star e2, e equal to e1 and e equal to id. Now the translation schema of above grammar is represented as first, for the first production rule, S gives id and e. So the semantic action, the semantic rule for this production can be written as p equal to lookup. What is given here? id. So id dot name. First you have to look up id, then if p not equal to nil, then you have to emit p equal to e dot place, else you have to place an error. So this is the semantic actions. Here emit function is used for appending the 3 address code to the output file, otherwise it will report an error. Lookup is used for looking up whether an id.name is provided or not. Okay. Now for the next statement, next production, e gives e1 plus e2. Let us write the semantic action. Now e dot place contains what? E dot place contain our id value. Okay. So e dot place equal to new temp of. So this is used for generate new temporary variables. So new temp of function is used for generating new temporary variables. Then what we are going to do? We have to emit. Emit is nothing but emit is used for appending the 3 address code to the output file. Okay. we are going to emit e dot place equal to what? Equal to e1 dot place, and what is the operator here? Plus is the operator, e2 dot place. Okay. Now for the next production, e equal to e1 star e2. So this is also same to it. E dot place, first we have to generate the new temporary variables, then you have to generate the 3 address code. That is e dot place emit of e dot place equal to e1 dot place. What is the operator here? Multiplication operator, e2 dot place. Next for this production, e gives e1. So that is equal to what? E dot place is equal to e1 dot place. The value of e dot e is equal to the value of e1. Next for the last statement, e gives id. So for this production, first if an identifier is given, you have to use lookup function to look up whether the id is present or not. So p is equal to lookup of id dot name. If this id is present, that is if p not equal to nil means, then what you have to give? You have to form a 3 address code, emit e dot place. Else what you have to do? You have to report error. So finally at the end of this production, our p returns what? Returns the entry for id dot name in the symbol table. As I told before, the emit function is used for appending the 3 address code to the output file, otherwise it will report an error. And new temp of is a function that we have used, that is used for generating new temporary variables. And e dot place will helps to hold the value of e. So this is how a semantic action for an assignment statement is used. Next for Boolean expression. So Boolean expression have 2 primary purposes. They are used for computing the logical values, and they are also used as conditional expressions, that is using if, then, else or while and do. Now let us see how a semantic rule can be framed for this Boolean expression. Consider this grammar. E gives e or e gives e and e gives not e gives e gives id relope id, and e gives true, e gives false. Relope is nothing but it is a relational operator. The relational operator is denoted by less than, greater than, less than or equal to, greater than or equal to, and so on. And or. So both operators are left associated, and not operator has higher precedence than and lastly only the precedence for or comes. Okay. Now let us form the semantic translations for these productions. So first production rule, e gives e or e. So for this what we have to do? First you have to generate a new temporary variable, e dot place is equal to new temp of. Next you have to form a 3 address code. So emit e dot place equal to e1 dot place. What is the operator here? Or is the operator, e2 dot place. Okay. For understanding purpose, let me write it as e1 and e2. Next statement, e gives e1 and e2. So and means what? And means only if both the statements are true, it is true, otherwise it is false. Okay. So for this also it is similar to the semantic action. E dot place is equal to new temp of, you have to generate the new temporary variables, then you have to undergo a emit function. Emit function is nothing but generating a 3 address code. So emit e dot place equal to e1 dot place, and what is the operator used? And is the operator used, e2 dot place. Now for the next statement, not e1. E gives not e1. So this is also similar to that. First you have to generate a new temporary variable. Next emit e dot place equal to, what is the operation here? Not operation, not e1 dot place. Next for the next production, e gives e1. So this is equal to what? E dot place. The value present in e dot is equal to the value present in e1. Next statement, id, relational operator and id. So for this first statement is e dot place equal to new temp of. First you have to generate a new temporary variable. Next you have to emit what? If id is given, if id1 dot place relational operator relope, id2.op operator, no, so reloop.op, id2.place, so let me name it as id1 and id2, id2.place, then you have to go to something. Okay, if a condition is true, you have to go to something, you have to go to some place. See, generally while writing a 3 address code, if a relational operator is given like this, first we will check for T1, you will check like this, then you will give a go to value. Then in the next statement, for 1 you will write like this, and in the next statement you will represent what? You will represent the else block. Okay, you will represent the value of the else statement. For example, T equal to 0. Then in the third statement, what you will do? You will represent where, after executing the else statement, where it has to go. That go to you will provide here. Then in the fourth statement only, you will represent the if statement values. Okay, that is T equal to 1. So if condition is true, it will go to where? It will go to the fourth statement only. That is, it go to the statement that is present in the third position from the particular statement. For example, where this fourth statement is present, it is present in the third statement, 1, 2 and 3. So next star plus 3 it will go if condition is true. So it will go to where? It will go to next star plus third position it will go. Okay. Then where you have to emit e dot place. This will provide what? This will provide the if statement. What is to be generated after a if condition is satisfied, that you have to mention here. For example, e dot place is equal to 1. Then next emit statement is you have to go to, so this is for what? This is for else block. So next statement plus 2, second statement it has to go. Then here the else block statement will be represented, e dot place equal to 0. Okay. So this emit statement is for representing what? Is for representing the else statement. If the condition is false, else has to be executed, no. So this will represent the else statement, and this statement represent after else where it has to go. See, for example, if this is the else statement, means after it is executed, it moves to the next statement. Here we will mention some go to value. So this go to value, it is present in the second statement. Next to this statement, the second statement it will present. For example, it will present in the fifth statement. That's why I have mentioned next state plus 2. And this emit function will represent the value of the if statement. That is, if condition is true, what statement has to be executed, that is represented here. Okay. This next state plus 3 will represent the go to statement when an if block is true. If an if block is true, it has go to next state plus 3. That is, it has to go to the third statement. Next, for e turns to true, simply you have to put e dot place equal to new temp of, then emit e dot place. True means what? True means 1. So e dot in place you have to store 1. That's all. If e equal to false means the same thing. Instead of e dot place is equal to 1, you have to write e dot place equal to 0. Okay. So this is how a semantic action for a Boolean expression has to be written. The only confusion is in the relational operator. If e gives id, relational operator id2 contains the next state and it gives the index of the next 3 address statements in the output sequence. Okay. Here in our example, where the output has to be represented, that has to be represented in the next state index field. As a summary, today we have discussed about the various representations of 3 address codes like triples, quadruples and indirect triples, and how each and every these representations vary from each other. Along with that, we have discussed about how to frame a semantic rules for some expressions like assignment expressions, Boolean expressions. We will discuss about the semantic rules for other types of statements in our next lecture. Okay guys, let me meet you all with another interesting lecture. Bye-bye.